What we really want to know is, what is the probability that a part will be outside of the spec limits? So we're going to calculate the associated K values, right? Just like with PPK and CPK, what you're really doing is you're just calculating how far your upper and lower spec limits are from the mean. In this case, we take the K value of our upper spec limit and our lower spec limit. Okay? Now that we have that, we know that the probability is 1 over K squared. So we know the probability of a random variable, a measurement, being greater than or equal to the upper spec limit. The maximum probability is 1 over K of the upper spec limit squared. And we know that the probability of our x being less than or equal to, LSL, is equal to, the maximum probability is equal to 1 over K squared. Okay, so how do we use this? Since we want to know the probability the part is outside of the spec limits, either high or low, we just use the higher probability because that is our higher probability of a failure. We just care what's the highest probability of this happening, right? Okay, so why is it called a high capability exemption? Well, most organizations, if they're using a high capability exemption, will have a critical value. So if K is greater than or equal to that critical value, the probability of producing an out of spec part is so low that we assume the effect of the distribution is negligible. Generally, this critical value is going to be 10, but make sure to check with your organization. Okay? Okay, so why do we still use capability then if we can just do this every time? Well, let's just assume our critical value is 10. And we're going to assume that our sample has a K value of 10. Okay, so our K equals our critical value here. So that means that either the upper spec limit or the lower spec limit is exactly 10 standard deviations from the mean, and the other one's farther away. So K equals 10. So this would be the lowest critical value, the lowest K value we could get to consider a high capability exemption. We don't need to know the distribution. Well, if K equals 10, then the maximum probability of a failing value, regardless of the distribution, is 1 over 10 squared, or 0.01, so 1%.